Today, I'm going to do a few things. To start, I'm going to want to test to see how much amperage is being pulled by different components in the electrical system on our 73 Mustang convertible. Now, the reason I'm doing this is because the Mustang convertible, without air conditioning and without the special high performance charging system, came from the factory with either 38 or 42 amp output from the alternator. Now, we've added to this car, on top of what it came with, a GPS with a battery, with a backup camera, LCD turn signal tail light, rear lights with sequential flashing, which requires a bit of current all the time on the sequential flasher circuits on left and right side. I added a webcam. I added a headlight relay, which causes the headlights and the running lights or parking lights to come on anytime the car is running. I did that for a few reasons, safety being one of them, and I used the relay that controls the current going to the headlights and the parking lights to power the turn signal sequential flasher circuits in the trunk, as well as a backup camera. Most recently, I added 2 cooling fans to the cooling system. So my concern is that now that I've added all of these different electrical items on here, the base alternator from the factory probably won't be able to keep up with the current demand. Oh, another thing we added was aftermarket air conditioning, which when the air conditioner is turned on, it causes an electromagnetic coil in the compressor area to pull current. Plus, there's a blower motor to get cool air into the cabin that also pulls current. Now, there are a couple of different ways to measure what is being pulled out of the system. I have an old school Sun brand VAT 40. VAT is an acronym for Volt Amperage Tester. It's a great system, but they're very hard to find. They used to be very expensive. Now you can get one used for a few $100s on eBay if you can find them. That's how I got ours. The other thing that I picked up is a digital voltage meter with an inductive ammeter clamp where I can measure up to 100 amperes of current flowing through a circuit without breaking into the circuit by clamping this around the wire that the current is flowing through. So to prepare for today's testing of this VAT 40, there's a little voltage selector down here. I'm selecting internal 18 volt, which means I'll be running on this green scale up to 18 volts, and internal simply means that the same connections I use to measure the amperes also measures the voltage. There's an external 18 volt setting I could use if I wanted to test a separate voltage output other than what's coming through the cables for the amper testing. So that's what I'm going to start with. I've already got the big positive clamp on the positive cable on the battery. The negative clamp I'm going to put to a good ground. In this case, I'll put it on the alternator mounting bracket. And to measure the amperes, it also has an inductive ammeter lead. Now you might not be able to see, but there is molded into this plastic housing a little arrow pointing in a certain direction. That arrow is supposed to point toward the battery on the positive side, or away from the battery on the negative side. I'm going to put this on the positive side initially. That way, any and all current that is flowing into or out of the battery will be measured. Now, before I can do anything, I need to come over to what's called a zero adjust knob. And I need to adjust this ammeter to zero when there is no current flowing. Everything on the car is turned off. So it was measuring about a 1/2 amp of draw. So I've now put it to a zero position. I can also check and make sure I have an accurate measure by taking my digital volt ohm meter and placing the ammeter induction pickup around the same cable and see if there's anything coming through. It also has the zero adjust, but in this case it's a button I push. And so when I push it, it sets the meter to zero. Hopefully it stays accurate. Okay, I will turn this around so maybe Linda can get a picture. But there is essentially 0 or 0.001 amp flowing right now, which is really nothing. So there's nothing coming through. So what I'll do first is I'll reach in and I'll turn on the ignition key to the run position. What that will do is it will activate the primary ignition system in the vehicle. It will also cause the relay that controls the headlights and parking lights to come on. And so we'll get a read of how many amps that is going to be pulling just in the run position with the car not being turned on, because I don't want the charging system to be charging.
Okay, do you want me to do that? Is the key in it?
I'll do it.
Okay.
But thank you for asking.
Okay. Stop video?
Oop. This only takes a moment.
Can you get around?
Yep. Come right through the passenger side. I guess you have to turn it off because I don't have the key.
That's what I was asking you. Are you ready?
Put it in run position?
Yeah.
Okay.
Okay, so 2 clicks to the right. It's in run position. Lights came on inside the car.
Okay. I'm going to reset this to 0 again, just to make sure it's on 0. Now, the ammeter is showing 14 amps, that's 1.4, are being pulled through the system right now. And this isn't showing anything. I don't know why. Okay, this electronic ammeter is showing 6.6 amps are going through. So one of these two is off by about 2.5 amps. Doesn't matter. it's okay. All right, now what I'm going to do is I'm going to turn on the air conditioner blower motor next and see how much more amps it pulls. This is showing 22 amps. This went into overload, which means I have to go to a higher scale. And it's showing 23.9 amps as opposed to now we're showing 21 instead of 22. The air conditioning fan blower is on the medium, and when I turned that fan on, you might have heard a click. That click was the electromagnetic clutch on the air conditioning compressor. Now I'm going to turn on the two cooling fans and see how much we're pulling. I'm going to do that with this thermostatic control switch. I'm showing 35 amps. Over here I'm showing 38.1 amps. I'm not sure which is the more accurate of the two. However, I am going to surmise this is the newer of the two units. This is about 40 years old. I'm going to guess that the small handheld unit is more accurate. So now what we're going to do is turn everything off, start the engine, back out of the garage a little bit so we don't get gassed by exhaust fumes, and I will test the alternator system to see what the maximum output is from the alternator and compare that to how much is being pulled. If it is a 38 amp alternator, it will not be able to keep up with the electrical demand of this car with the air conditioner turned on medium and the fans turning for the cooling system. So the battery will be drained continually. If it's a 42 amp output alternator, it will be marginal amount of charging available. In any event, I'm guessing one of my upcoming videos will be me removing the alternator so I can send it out to have it rebuilt with high output components, more windings in the stator, more windings in the rotor, trying to get up to 95 or so amps out of it. Not that we need that much, but sometimes more is better works. We'll be back in a few moments. Okay, I'm going to ask Linda to once again put the ignition in the run position because I want to measure the amperage being pulled by the cooling fans before we start the engine.
Okay, so 2 clicks.
2 clicks.
Okay. Engine light on.
Okay, I am going to be measuring around the 2 red leads that go to the cooling system fan to see how many amps they pull all together, because I'm curious. 15.3.
14.2 over here.
Oh, it dropped? Okay. Now it's 14.5. Okay. You can turn it off.
Turn the car off.
So these fans pull about 7 to 7.5 amps each, which is a significant additional drain on the electrical system, which means that the alternator is putting a load on the engine to get that energy. But the way I have this set up is that when the coolant flows through the upper radiator, there's a thermocouple I put inside the radiator hose and sealed. And the fans will not come on until the temperature hits approximately 200 degrees Fahrenheit. This is a 195 degree thermostat, so it runs when the engine is warmed up at a minimum 195. If it's running 195, 196, I don't need to start cooling off the radiator for coolant yet. And if I'm going down the highway, I should have airflow coming through the radiator to take the heat off of the heat exchange unit of the radiator. But if I'm idling for a long period of time or driving at slower than 20, 25 miles an hour, the airflow from the car moving forward will either be non-existent or not enough to cool off the radiator cooling fins. So no heat transfer effectively happens and the cooling gets too warm. So the idea is if this coolant coming in from the engine into the radiator hits 200 degrees, the thermocoupler will signal the rheostat system, and that will trigger the fan relay, and that will turn the fans on. And so in theory, only when we're 200 degrees or warmer with the way it's set now will the fans come on. So it's not like we'll be pulling electrical energy all the time off the fans. If they're needed, they're needed. If they aren't, they aren't. That is in comparison to the stock system where there is a manual fan blade attached to the front of the water pump pulley that is always pulling air and hitting air resistance. The faster the engine is turning over, the more the resistance. So it's always pulling power. So in theory, this is a more efficient setup. In reality, it doesn't matter that much, but it is something worth at least noting. So now, I know that I'm pulling about 37 amps with the car running, air conditioner turned on medium speed, cooling fans on, of which almost half of that draw is coming off the cooling fans. So now the question becomes one of what can the alternator put out? Well, there's a few different ways to measure that. The quick, dirty, simple way is to use the inductive ammeter on the engine when it's running about 1500 RPM, 2000 is even better, and I load the battery or the electrical system with an outside carbon pile load, simulating a draw on the system. That will cause the voltage regulator to see a drop in voltage, and it will send more current to the field circuit on the alternator and make the alternator start putting out more power, amps and volts. That's one way of doing it. Now, the downside of doing it that way is it doesn't really give us a maximum of the alternator per se, because we don't know if the voltage regulator is fully energizing that field circuit or not. We're assuming it is. So the other way is to disconnect from the voltage regulator the wiring harness and introducing into the field circuit full battery voltage, in this case about 12.8 volts, going directly to the field circuit of the alternator, and that will force the alternator to provide maximum output at the RPM the engine is spinning at. I'm going to do this both ways. And the other thing I have to be careful of is I can't just measure it from the battery cable, because if I do that, I'll be getting a measurement of total amps coming in minus total amps coming out. So if I'm putting in 38 amps and pulling out 35, this might show the alternator is only putting out 3 amps. Well, that wouldn't be correct. So what I need to do is locate the cable that leads down to the alternator charging circuit and either put this ammeter inductive lead over it or this. This is easier. So I'm going to do that off camera, get this whole thing set up, get the engine started, and show how it is that I test output of the alternator for maximum, so we have an idea of how weak the alternator is compared to what it needs to have. We'll be back in a few minutes. Okay, the fan for the cooling system had turned on for a moment, just turned off. And idle, we're creating a net output of about 6 amps. I'm going to go ahead and turn the fans on and show you what happens when I put a load on the system.
That's negative.
Now we're pulling voltage out of the battery. Voltage dropped to 12.8. I turn off the fans by turning the temperature sensor up higher. We're back about 6 amps output and about 13.1 volts output. Now what I'm going to do for my next trick is put a load on here. Now come around and I'll bring the RPM on the engine up to the alternator puts out more. Load light is on, so we're putting a load on the system. And I'll start raising the RPM, and we'll look to see how many amps and volts we can get. About 15 amps and 13 volts maximum output. Yeah. That's not that great. Now I do have a smaller inductive ammeter hooked up, but it's down in the cable area that will be very, very hard to read or show in the camera. But I will tell you this, if we take the 15 or so amps we were getting, add to it the 17 amps we were pulling before, actually it's more than that, it's about 20 something. I bet this is a 38 amp alternator. Now not very much. So my decision has been made. I'm gonna pull the car back in, or have Linda pull it in, let it cool off, remove the radiator, send it out to get it rebuilt with high performance components.
Alternator, not radiator.
Alternator, thank you. And then we'll test and see how it performs. So with that, I will ask Linda to kill the engine so I can unconnect all this stuff.